Hi everyone. Today we're building an agentic AI chatbot for Google Maps from scratch using AutoGen and Model Context Protocol or MCP. And we'll develop a simple web application for that. Imagine asking your agent to look for places, give you directions, or do any other related task with Google Maps. We'll write every single line of code together. We'll face every error and roadblocks along the way, and we'll figure out together how to exactly solve those issues. Because this is how you really learn how to develop AI agents and agentic AI projects. So, without further ado, let's start. Okay, so as we've done this several times before, we'll do this project in two parts. Initially, we'll build the AI agent, and once we're done with the AI agent, we'll develop the web application using Streamlit, and then we're done. So, let's start with agent.py to handle the AI agent. And for the AI agent, we'll be using assistant agent class in AutoGen. And for the underlying LLM, we'll be using O4 Mini. But you can also use other LLMs such as Ollama models, which are open source. And you can take a look at my previous video on Ollama and how to work with those open source LLMs. But for this video, I decided to use O4 Mini since it's really smarter than many other open source models. And it is also much faster to execute because I'm just using the API and OpenAI is dealing with the processes. So it's super fast. So from AutoGen, agent chat.agents, import assistant agent. And for the underlying LLM, from autogenx.models.openai, import OpenAI chat completion client. And as we've seen this in previous videos, AutoGen works with async IO, so I also need to import async IO as well. For now, let's create a main coroutine, and my model, my LLM, will be OpenAI chat completion client. The model will be O4 Mini. And I need to provide the API key. I've stored the API key in API underline OpenAI.text, so I can easily read that one. Open API OpenAI.text. .read to read the whole file, and .strip to make sure there's no extra space or new line at the end of the file. And now we go to agent. We'll make an assistant agent. We should name it. Let's go with agent. And I need to provide a system message, a set of instructions for the agent. In previous videos, as you remember, I've done this here, but for a different or maybe better organization of stuff, let's do this in a separate file. I can say agent.text, and here's the instructions. You are a helpful assistant. You will be given a task to complete with Google Maps tools. And just as this seems to be a better practice in prompt engineering for such agents, I can initially ask it to plan and figure out a set of actions needed to accomplish the task, and then to follow those instructions step by step. So initially, figure out a step-by-step plan to complete the task. Then execute the plan step by step, providing just this one, step by step. And for now, this seems okay. Let's just import it. Let's read this file. Open agent.text.read.strip. And I also need to provide the LLM as model client. And okay, now we have an agent we have an underlying LLM for that, but we still need to provide the MCP server for Google Maps. And for the Google Maps MCP server, let's take a look at their webpage. MCP servers for Google Maps. Let's see which one. Yes, this is Google Maps. You can see there are a bunch of tools here, but we need to get an API key. That's free, but you need to follow these instructions here to get your API key. Of course, the instructions are really easy and straightforward. I'm sure you can handle it. You just need to click on this button, go to the credentials page. You need to enter your credit card details, your credit card credentials. Of course, they will not charge you. They just want to make sure that you're a real person. And then you'll have your API key. So once you have your API key, I suggest keeping it in a separate file. And of course, do not publicize it. It is yours. And it is free up to a limit. If you use it 1,000 times or 1,000,000 times, then maybe you'll be charged. So, but for this project and for simple illustrations, it's fine and it will be free. And we have two ways to use MCP server for Google Maps using Docker or npx. I'll use npx today. So this is the command, this is the arguments for that command, and then we need to define this environment variable. Okay, and of course this MCP server for Google Maps, it runs locally on your machine, so we need an stdio server for that. So I would say from autogenx.tools.mcp import stdio server params and also MCP Workbench. That's it. And now let's define the parameters for our server, stdio server, and I need to specify the command, which is npx. I also need to provide these arguments. Let's just copy it. So arguments will be this one. And I also need to define these environment variables. It takes a JSON. And here it is. Now let me read my API underline maps.txt. And it seems to be okay. Now I need to create an MCP workbench and provide that workbench to our agent. So here's what I can do. I can say async with MCP workbench, and the server params will be these params as workbench. Now I define my agent inside this context, and I'll provide the workbench to the agent. And now I can, let's test it. Let's make sure everything's all right. Result equals await agent.run, and I need to provide a task. Let's store it in a separate variable. Task will be, for example, find a nice cafe near downtown Ottawa. And then I will print this result. Now I only need to create an event loop and run this main coroutine inside that. You see, async io.run, it creates an event loop, and then it runs the main coroutine. Now I can say Python agent.py. Let's see what happens. Okay. We're seeing we have some problems, and this is totally normal. So we have the initial message from the user, find a nice cafe near downtown Ottawa, and then we have a tool called request event. This is fine. It has requested for maps geocode. I guess it's for, fetching the coordinates for downtown Ottawa, and nothing else. It has got the result for the geocode and nothing else. So one thing we need to do is that, there's this flag here, there's this argument, reflect on tool usage. It basically says that, okay, once you've called for a tool, after you have the result, you need to also process that result and say something about it. So let's do it now once more with reflect on tool use set as true. Yes, you can see at least we have one text message after the tool call. Here it says that here's the plan I'll follow. 1, use downtown Ottawa coordinates, which is this one. 2, search for nearby cafes within about 1 kilometers. 3, pick a highly rated cafe and fetch its key details. And now we're in step 2, searching for cafes near downtown. And you see, nothing happened afterwards. So honestly, it's also good if you pause the video and think about it, or even if you search about it, about what's the problem. First of all, think about it, and then if you haven't figured it out, go on and search about it. But what's the problem here? The problem is that for one single agent, when you use run or run stream method, it just does one step, one shot. If it has some tools, it can call one tool and then it can reflect on that tool just once. But obviously, for many different tasks, especially for more complicated and sophisticated tasks, you need to accomplish that task in several steps, not just in one step. So here's what you need to do. You cannot do that with a single agent in AutoGen directly. Instead, you can create a team. If you remember from our previous videos, we've worked with different kinds of teams in AutoGen, like RoundRobinGroupChats or like selector group chats. The thing is that previously we've worked on teams of multiple agents. We had 2 or 3 agents in one team. But you can also make a team out of just one agent, a single agent, and that team can, run that agent several times, can make that agent process the information in several steps. So here's what we need to do. We need to create a RoundRobinGroupChat team of our agent and call the run or run stream method for that team, not that agent. So I can say from AutoGen Agent Chat.teams import RoundRobinGroupChat. And now I can easily say team equals RoundRobinGroupChat. I need to specify the participants, which is just the agent right now. And what is the max turns? The maximum number of turns will be, let's say, 10. Well, let's go with 5 for now. Okay, so instead of running the agent, I can run the team. And let's see. You see, it's taking some time. And the main reason is that we're using the run method, not run stream. I'll tell you about the differences between them. For run, when you call the run method, it waits until it has all the messages for all steps and then it shows them together. But if you use run stream, and of course run is a coroutine, and or think of a coroutine as a regular function in async, but in async IO. But run stream is an async generator. It's not like a function or a regular coroutine. It's an async generator. It returns each message. It yells each message once it's generated. So it gives you a much better user experience. Once you have a message, you can immediately display it to the user. Okay, so we have something now. Let's see. Initially, it was, okay, this is our message, the user's message. Find a nice cafe near downtown Ottawa. We have some tool calls. We have some reflections from the agent. And let me see the final message. Okay. This seems to be the final message. Yes. I recommend Delicat Cafe, an easygoing, well-reviewed spot right in downtown Ottawa. This is the name, this is the address. And yes, we have some information. And let me know if you need another pick. And what is the stop reason? The stop reason is that maximum number of turns, which is 5, have reached. Okay. So, for one thing, this cannot be a very effective approach to terminate the conversation, because let's say a task needs more than 5. Let's say a task might need 7 steps. So first of all, we don't know beforehand, so we should set max turns to some large value so that we're sure that in most of the cases, or better than that, in all of the cases, we have enough steps. We can afford enough steps, but at the same time, maybe a task is easy and we don't want to waste all of our steps. So let's run the same task again. And of course, let me stop it. Instead of using run, now let's use the run stream method. And since it's a generator in Python, we should iterate over it. So async for message in team.runStream using this task. Just for better distinction of different messages, let's add some dashes before each message and then print the message. And now we can see the messages gradually while they're being generated. You can see this is the user's message. Find a nice cafe near downtown Ottawa. Then we have a tool call for maps geocode. And then we have some tool called results, which is this one. Here's my plan. Use the geocode location for downtown Ottawa to perform a nearby search for cafes within about 1 kilometer. And 3, review the top results by rating and proximity. 4, fetch detailed info, hours, website, phone. And 5, present a recommendation with all the key details. Okay, now I'll execute step 2. It has searched for some cafes. We can clearly see the results here. Not clearly, but we can see the results here. And here's the reflection of the model. Here's the top peak right in the heart of downtown Ottawa, Delicat Cafe. And this stands around 300 meters north of Wellington. Okay, this is the phone. This is their website. This is their working hours. And then what's the next step? Okay, now we can see the problem. It has suggested the cafe. It has said, enjoy your visit. And then it continued again. Well, we don't like this to happen. Once we have the result, we want to terminate the conversation. We don't want to prolong the conversation. So you see lots of repeating. So we need to come up with a termination condition to terminate the conversation. So we have a whole bunch of classes and conditions for terminating a conversation or a chat in AutoGen. From AutoGen Agent Chat.conditions, we have lots of options. In our previous videos, if you remember, we've used text mention termination. Yes, text mention termination. And you can look at our previous videos. Of course, in those cases, this worked for us, other than just one video, if you remember. In one of our videos, I guess it was the archive agent. In that video, sometimes you see because this is how it works. We tell the agent that, okay, once you're done, you should exactly say terminate with capital letters or any other expression. And the problem will be that in the intermediate steps, the agent sometimes, says, okay, still not the time to say terminate. And right at that moment, AutoGen terminates the conversation because the agent has actually said that expression. So I asked in one of the videos, what do you think might be a good solution? Leave a comment about it. And so far, as I remember, no one has said the right answer to that question. Now I'm gonna reveal the answer. We don't need to use text mention termination for the task or for the use cases that are a little bit complex, or the agent might mistakenly say that expression inside its steps. Instead, what we can do is that we can make a condition on function call. We can have a redundant function, let's say def terminate, and it's not important at all. We don't need any content for this function. We just need to define it, and we can ask the agent to call this function once it's done. This way, if even the agent says the name of the function, for example, in one of the intermediate steps, it says, okay, now it's not time to call this function, nothing happens. Only once the agent calls this function, then we'll terminate this conversation. So instead of text mention termination, I can say function call termination. And I also need to provide this function to my agent, and also include it in the agent.text and say, okay, once you're done, call this tool. So once you have completed the task, call the terminate function to end the chat. Okay, so if I want to do it the usual way, if I want to say, okay, I have also some tools, and that tool will be the terminate function, we'll have a problem. Let me show you the problem now. And of course, I also need to add this condition here, but let's wait for that. So if I want to run this one, I'll get an error. As you can see, tools cannot be used with a workbench. So the problem is that we can separately have some tools, or we can separately have a workbench, or even several workbenches, but we cannot have tools and workbenches at the same time with AutoGen. So what can we do? There is a simple method to tackle this challenge. I can say instead of MCP Workbench, we also have another method, another tool. It is called MCP Server Tools. And instead of creating a workbench, I can easily say MCP Tools equals MCP Server Tools. I can pass the server parameters as well, and it will give me the tools in that MCP server, just like a regular, just like regular tools in AutoGen. So I have MCP tools now, and now for tools, I can say my tools will be MCP tools plus terminate. And it's also beneficial to provide some documentation tool to terminate the chat. Yeah. And this will be my tools. I also need to make sure the indentations are correct. And I guess it's fine now. And now I need to specify this termination condition. So the termination condition will be a function called termination. I need to provide the function name. Function name will be terminate. Now let's see if it works. Oh. Okay, I need to await this, yeah, because this is a coroutine. Yeah. You see, it's working. This is the user's message. Here's the plan I'll follow. Use the geocode, search for cafes, sort the results by rating and select a few top highly rated cafes. Present their names, addresses, ratings, and a brief note. Now executing step 2. You see, it's going on. And here are 5 highly rated cafes. Okay, we've got some. And you see, now it's called the terminate. And just as soon as it's called the terminate, of course, the step should finish. It has also a reflection after that. Chat ended. This is the reflection, and we're done. So this is exactly what I was planning for. And now we can start developing the web application with Streamlit. So let's say we do it in app.py, and just like before, let's import Streamlit as st, and also let's import async.io. And it will be much better if I turn this main coroutine into 2 coroutines, one for configurations and the other one for orchestrations. Just like our previous videos, I can say async def config, and I will move everything up until this task to that config. Okay. And in the end, I'll just return the teams. So return the team. And then I'll have an orchestrate coroutine. It gets a team and a task, and it accomplishes the task. But let's also have a main coroutine. Inside that main coroutine, I'll create the team. I will define the task. Now I don't need the task in orchestrate. And then I will await orchestrate. Okay. So this should work now. Let's just run it for 1 or 2 messages to make sure it's working. Yes, you see, it's working. But there's a problem here. Although this orchestrate works fine in this script, and this script standalone is quite working, but the problem is that I wanna be able to display the messages once they're being generated inside my app.py, inside my Streamlit web application. And if I wanna call this one, I should wait until all of this for loop is done, and I have all the messages together, and then I can display it. Just the same problem we had with run method rather than run stream method. So here's what I can do. I can turn this into an async generator so that I yield every message once I have it. And then inside my Streamlit app, I can iterate over that generator. So instead of printing them here, I can simply yield message. And now, instead of doing it this way, I can iterate over this generator. For message in orchestrate team and task, just like before, let's have some dashes and print the message in the main coroutine. Now if I run agent.py, I'll not wait until it finishes. You see, it's working. So we're good to go. So I need to import these 2 coroutines as well from agent, import, config, and orchestrate. So for the beginning, I will say, okay, a title, Google Maps agent or chatbot or whatever. And I'll need a container to display the messages. So I would say container equals st.container. And I'll have the task as a chat input. Enter your task here. And let's also include an example. And now, if we have a task, if the user has entered something, now we should run the agent, we should orchestrate the team, and we should display the results here. So I need to create the team. So async.io.run config. We're done. And now I'll need to make a coroutine here. Async def run agent. That's fine. And that agent gets the team and the task. And just like what we've done in the main coroutine of agent.py, I can iterate over the messages in orchestrate of team and task. And now I can display the messages, but I want to display them, a little bit more beautifully. So if the message is from the user, I want to show it with a different avatar. Or if the message is from the agent, I want to show it with some AI avatar. So I need to make sure that, is the message from the user or from the agent? And of course, at the end of our orchestration, this message will not necessarily be a text message. It will be a task result object because, let me show you. Once you run the run stream method, if we take a look at the documentation, let me see. If I say team.run stream, I want to show you just the documentation. So it will be an async generator. It can return a base chat message or a base agent event or a task result. And it will return a task result in the end, once it's done and it has all of the messages. So I don't want to display the task result object. I just want to display the messages. So I should check. I can say from AutoGen Agent Chat.messages import task result, or maybe it was in Teams, I'm not sure. Task, do we have a task result? No. Or maybe it was in base. Yeah, I guess it was in base. Task result. Now I need to check. If not, it's instance of message and task result, meaning that if message is not a task result object, then check. If message.source equals user, then I need to display the message inside the container. So with container and with st.chat message from user, st.markdown message.content. And similarly, if the message source is agent, then inside the container displayed with the avatar of assistant, and these two, assistant and user, are predefined avatars in Streamlit. Okay, I guess it should work now. Now I can just run this coroutine. I will build an event loop and run this run agent coroutine. And just for a much nicer UX, let's say st.spinner running agent. And once we're done, I can say st.success. Task completed. That's enough. So let's see. Streamlit run app.py. Okay, we have Google Maps agent. I can say find a bookstore in downtown Ottawa. Let's see. Find a bookstore in downtown Ottawa. It has called for a function. I don't want to display the tool calling like this. It's so ugly, but let's go on for now. I look for a bookstore within about 1 kilometer of downtown Ottawa's center. You see, absolutely ugly. And where's the spinner object? Here's a great option, and we're done. You see, perfect books here, and we're done. And it is called Terminate. Goodbye. So for one thing, I would like to display these, function tools in a much better way. So let's say I also want to check if it's a function tool, I want to display it with an expander object in Streamlit. So if the source is an agent, I need to check. If it is a text message, then I want to do it this way. Otherwise, I want to display it in an expander object. So let's import. Since I need to check for text message, from AutoGen agent.messages import text message. And now I can say, if it's a text message, then do it this way. Otherwise, I want to use a st.expander object. Tool call. Yeah. and just st dot. I'm not sure if this is the best way, but let's go with st.json of message.content. Let's see if it works. Okay, suggest, let's say, a bookstore in downtown Ottawa. Okay, we have tool calls. Yes, this is much better. But, you know, having it display like a JSON, you know, we have such problems. So I'm not sure, maybe it's better to display it in some other method. But we have the step-by-step plan. Now executing step 2. Here's a great independent bookstore, this one, and that's it. But now we have two problems. One problem is that I want to follow up our discussion. I want to say, send me their Google Maps link. And let's see what happens. First of all, our previous chat is somehow removed or is somehow destroyed. Could you clarify which place or listing you'd like the Google Maps link for? Sure, you could let me know the name. I'm ready to fetch the Google Maps link. Could you please provide the name? Sure, please let me know. You see. So here we have a problem. It doesn't keep the memory, the history of its chat, and also once any event happens in the page, once I click or I enter or I do whatever, the previous chat which was rendered will be cleared. So what should I do about it? Well, I need to keep the memory, I need to keep a history of our previous chats for Streamlit, just for displaying the messages. And I need to display those messages after each event in Streamlit. And I also need to save the most recent state of the team, and I need to load that state every time the team is created. Because you see, whenever we have a new task, we go inside here and we create a new team. So that team is not aware of what it has seen, what was happening in the past. So we should load the state for that team so that now the team is completely aware of what was happening before. So we have Streamlit session state for this. I can say if I can assign a messages variable in session state. If messages is not in session state, then create one. It will be an empty list for now. And once I have a new message, and of course, if it's not a task result, I want to store that message in messages. So this is what we need to do. st.sessionState.messages.append message. So now we're storing the messages, but we also need to be able to display the previous messages as well. So that's why I will create a show function. Let's say def show, and this show gets the container. And now I can say for message in st.sessionState.messages, just do these operations. Well, I have two options. I can copy these ones. Let's do that for now, but this is not the best approach. I can just easily copy these comments to display the chats. So I can say, if this message is from the user, then you need to display it this way. Otherwise, if it's from the agent, you need to display it this way. And once before getting the task from the user, I will show the previous messages. This way, I will always have the previous messages, and the new messages are added at the bottom. So I have this one, and oh, I forgot to fix this one as well. With st.spinner, run it. This way we'll have the spinner as well. So let's see if the first problem is solved. Okay, find a nice cafe near downtown Ottawa. Okay, we have some tool calls. Okay, here's a great peak, enjoy your visit, and we're done. Now I can say, of course, it doesn't remember the history even now, but I just want to make sure that my previous chats are there. What did you say? You see, our previous chat stays. I'm sorry, could you clarify what you're referring to? Which part would you like me? I'd be happy to reply. And it keeps saying the same thing again and again. We need to fix this inside its system message as well. But the first problem is solved now. And let me go to its system message and say, if you cannot solve the task for any reason, or if it's the user's turn to respond, call the terminate function again. I guess this fixes the problem we were experiencing. And now we need to store the team state as well. Inside this task condition, this if statement for task, now I can say, okay, here I have the team. If I have a previous state for the team, if team state in st.session state, then load the team state, await team.load state with st.session state.team state. So if we have a previous team state, it will load that into the team. And since this is, this await, this is for a coroutine, I should move this inside the run agent coroutine. Okay. And once I'm done, after this for loop is done, I can save the team state. st.session state.team state will be await team.save state. That's correct. Okay, and now everything seems fine. Let's just run this once again to make sure it's working. Now I can say, suggest a nice cafe near downtown Ottawa. Okay, we're running agent, and you see one avatar for the user and another avatar for the agent. You see another avatar for the agent. And we're done. Here are a few highly rated cafes within about 10 or 15 minute walk of downtown Ottawa. Okay, now I can say, for example, how long does it take to walk from Rideau Center? It's a shopping mall in center in downtown Ottawa to the third one, the Planet Coffee. I just want to make sure it knows the previous history. And I can see what it is called. You see, it is called the maps distance matrix, and the arguments, the origin is Rideau Center, Ottawa, the destination is this one. So it seems to be working fine. It's about a 0.8 kilometer walk from Rideau Center to Planet Coffee at this address. Okay, nice. I can also ask another question. For example, is Happy Goat open on Tuesday morning? Again, we have a tool call. Map search places is looking for a Happy Goat. It has found it and now performing lookup for operating hours. You see, maps place details. It is calling this tool. Yes, Happy Goat Coffee in World Exchange Plaza is open Tuesday mornings from 7:30 a.m. until 3:30. Send me a link to their Google Maps page. It's actually funny to chat with it. Yes, here's the Google Maps link. Let's see. Oh, it wasn't found. So I can say the link is not correct. Look for it again. Okay. Now this works, you see. So, as you've seen, we've made a chatbot for Google Maps. You can do Google Maps operations with this chatbot, and it works pretty fine. So that's it for this session. I strongly encourage you to go ahead and do this yourself. I hope you've watched this video completely with focus, but now it's your turn. Go ahead, start from scratch and try to come up with a chatbot for Google Maps. So I hope you enjoyed this video. Don't forget to leave your comments if you have any suggestion for my next videos or if you have any improvements for this one. I hope you enjoyed it. Until the next time, take care.